Now, from our previous session, we have seen that there could be, if we are to pick, we would probably go ahead and pick and risk, but for one reason or another, we have implemented computers, quite a number of commercial computers using CISC. Now, and of course, the execution time is computed using the formula below for the CPU time. Now, we can look at the super pipelining architecture, what we call Superscalar. Basically, what happens here is that aside from pipelining, we have processors that can execute several instructions concurrently because they have multiple execution units. When that happens, it means we can cut down the clock time. Internally, the clock time can be multiplied so that one instruction, one clock cycle can serve two instructions at the same time. This is what we call Superscalar architecture, and it could have we say if it, for instance, it has those two multiple execution units, then you say it's a two-issue machine. It's as simple as that. Now, let's have a look at the computer instructions. A computer must have instructions capable of performing the four types of operation. One is data transfer between the main memory and the CPU register, arithmetic and logical operation on data, program and sequencing and control, and input-output transfers. We've seen that based on the few examples we have just done. Now, the most common fields found in an instruction, because an instruction will have some fields, are an operation code field that specifies the operation to be performed, an address field that designates either a memory address or a code for choosing processor registers, and a mode field that specifies the way the address field is to be interpreted. I'd like us to look at what happens with specifically with the accumulator registers. If you can do accumulator organization, you can either have an instruction that specifies an arithmetic addition which has only one address field symbolized by, for instance, memory location X. So when you say add X, it means you take X and add it to whatever is in the accumulator register. That way, we avoid using two. We shall look at that later. Then multiple register organization, you see that we specify more than one register. Like in this case, 3 registers are specified. Quite often the third one is going to be the storage register, or two may be specified, in which case the first one ends up storing the data in the accumulator from where it is now read. Move, we basically specify move from where to where is it therefore has to take two registers. You can see now, and of course you can see these are multiple registers, and these instructions now are very common, but most of the time when you're doing assembly language, you discover we have two instructions. Sometimes you'll be forced to use three, so you use a combination, not just one. And you can see two address operations like these ones, one address instructions where we have pop, add, load, store. It means they are working with the accumulator. That's why you're referring to them also as accumulator. You can see the accumulator register here. Accumulator is a very powerful register, denoted as AX in assembly language programming. Where we have zero address, we have push A, push B, and so on. We have zero address instructions. They work with the stack. Now, I would like us to have we can use different instruction format as we have seen. You can either use the single two address format like you can see here. You can also use you can see two address format, that 6-bit per operand field. The number of address averages from would be 2 to power, and that 6, which is 64 megabits. Addressing and assembly language. Addressing techniques which are used in assembly language. I wish you had a chance to do this assembly language. So we have immediate addressing, where you can use a constant. This is how you of course in most you can use this to know this is a constant, and then you have the register. So you can say move the constant to a particular register, and you can see, for instance, the example load 5000. That's 5000 is is loaded into accumulator. Direct addressing is where we have the address itself specified, the memory address from where we are getting the value to the accumulator register specified. So that's the memory address. 7000 is not a figure; it's a memory address. Like in the example we had, whatever is stored in 5000 is ABCD. So is ABCD equal to the accumulator?